What other ones? Sure. Question 5. Okay. Number 8?
Yeah.
Okay, yep, I can add that one to the list. Okay. Any others to add to the list here? We've got plenty of time. If we need to, we can add more, but we'll start with these. And then if we need to, we can add more, and then we'll move on then to 2.5, which is the beginning of applications. So those are going to be using words and variables together to solve questions. So we're now going to look in 2.3 and 2.4. We're going to begin with question 5. Okay, and what we've got on question 5 is we've got 1/5 times 10x minus 15 equals 1/3 times 9x minus 6. So what we're going to look at first is our order of operations. And what do we need to do first? Well, before we clear fractions or do anything else, we always need to first get rid of our parentheses. Now the fractions are going to be nice and they're going to go away because when we look at these, what do we know about 10? Okay, 10 is evenly divisible by 5, right? 15 is evenly divisible by 5, so those are going to go away. 9 goes into 3, and 6 goes into 3 as well. So let's go ahead first and distribute through our fractions here. So we're going to take our time and we're going to distribute. Now, what do? Divide by the number down below, multiply by the number on the top. Okay, so 10 divided by 5, that's a 2, times the 1 in the numerator makes it a 2x. And we'll bring down our negative. 15 divided by 5, that is a 3. Yep, times 1 still stays a 3 there. Next, when we distribute through, 9 divided by 3, that's a 3. Times 1 makes it a 3x in this case. And 6 divided by 3, 6 divided by 3 is a 2. Sign comes down with it, so that's going to be your minus 2 there. So the fractions were nice because they went away. Now if we had some left over, we would clear them at this point. But we always do our parentheses first, so we distribute through first. Then we clear out all of our fractions. Now we need to solve this. So what's our goal? Well, just kind of a refresher. When we solve equations, what do we want? We want our variables on the left, right? Numbers on the right. So I'm going to go ahead and move that 3x over. And when I move that 3x over, I have 2x minus 3x. That makes it a minus x. Minus 3 equals that minus 2. Next step, we're going to move that 3 over to the right-hand side. And now we've got minus x equals 1. And how do we finish it from here? Well, can we have a negative x? Nope. What do we want? We want a positive x. So how do we get rid of the negative 1? Negative in front, we divide by a 1. Negative 1. And so then what's my final answer? Well, my final answer is x equals a negative 1. Is everyone okay with how I solved that? And when you work on your homework questions, you could do that minus 3x and also add that 3 at the same time. If you want to combine steps, you can do that. When I work things out, I generally don't. Sure, yep, no problem.
Sorry about that.
Yep. But when I work them out, I show all the steps. When you're working yours at home, you can kind of skip steps if you're careful. But you don't want to make mistakes. It might almost be better to just write out all the steps and to accidentally lose a number somewhere. So that was question 5. And it's very important that we know how to work these out, and you'll get better at them as we work through more of them. So question 7. And this, by the way, is 2, 3, and 2, 4. And question 7 is a minus 5y minus 2 minus parentheses minus 4y plus 9 equals a negative 1. Okay, so let's think about what we do first. Well, the first thing we want to do is we always begin with the parentheses. And if there's a negative in front of that parentheses, that is going to get distributed through, and that is going to change all the signs inside. So we're going to draw our arrows here and distribute those negatives through, see what we've got, combine like terms, and then eventually solve the equation. So that leaves it when I distribute that negative through. It's going to switch my signs around. So that leaves you then with a minus 5y, a positive 2, negative and negative makes it a positive 4y, negative times that positive 9, that makes it a negative 9. And that equals now a negative 1. So is everyone okay with what we did first? We got rid of our parentheses. Now, before we move things across the equal bar, very, very important, we need to combine everything that we can on the left-hand side. So always want to condense it down as much as possible. So what can we put together? Now the minus 5y and the positive 4y, those are like terms. And so that's minus 5 plus 4. That's going to leave you then with a minus 1. So that's going to be a minus y there. So those go together. The 5 is negative and it's the larger number. Now we look at the 2 and the negative 9. 9's a larger number. It's negative. So 9 minus 2 is a 7. So let's bring that negative sign down. And that's going to be a 7 there. And then it equals a negative 1. Is everyone okay with that so far? Now we're almost done. What do we need to do? Yep, add that 7 over so it moves over. And then we've got minus y equals positive 6, it looks like. And can we have our answer as a negative y? No. What do we always have to do? If it's negative, divide by a negative 1. And that leaves me then with y equaling a 1. Yep, negative 6 for your final answer. And just take your time with these. Don't rush through them. Always be careful. It's so easy to make a sign error or accidentally add something together wrong. So always try to take your time and try to be as neat as possible. A lot of times students make mistakes because they can't find their work. Question 8. Question 8 might be a little bit different here because we're going to see what we've got. This one's not going to be conditional. This will be something else. So for question 8, we've got 6 times x plus 4 minus parentheses 6x plus 24 equals 0. Now remember, in this section we learned about the 3 types of equations. So there's conditional where you get an answer. There's contradiction where it's a false statement. And there's the identity where the sides are the same. So the other 2 that we've looked at, they were conditional. This one is not going to be conditional. Because once we distribute that negative through, then my variables are going to cancel. And so we'll distribute the 6 and we'll distribute the negative through. So now when we distribute, that gives me 6x, and then 6 times 4, that makes it a 24. When I distribute the negative through, I get a minus 6x, a and minus 24. Now, what's going to happen on the left-hand side? Well, these are all inverses of each other, opposites, and they completely cancel, and they leave you then with 0. And 0's on the left, 0's on the right. 0 does equal 0, so this is a true statement. They are the same, so this is called an identity. And our solution set is going to be all real numbers. Okay. So does everyone see what I did there? Why it's an identity. Now, if this would have been a 5 equals 0, that would be false, and that would be a contradiction. Okay? So if they are true, if they are the same, it is an identity. If the variables are gone and they are different, that makes it a what? Contradiction. Okay? And if you get x equaling some number, that's called conditional. And most equations are conditional. So let's now move on to question 11. And we can add more if we need to. It's very, very important that we understand how to solve these equations, because this is one of the fundamental building blocks of all the next courses is how to solve equations. So 11 has fractions, and we're going to learn how to clear the fractions again. So we've got 2/3 y minus, parentheses, y minus 1/4 equals 1 over 24 times y minus 8. Okay, so let's see what we can do here. Well, first thing, before we clear out fractions, very first thing we have to do is deal with these parentheses. So before we clear those fractions, deal with those parentheses. So now we're left with 2/3 y. We've got a minus y. Negative and negative makes it a positive 1/4. On the other side, let's see what we've got. How do we multiply this fraction through? Well, nothing can cancel. So we just take that 1 times y, that's just a y, and that's going to be a y over 24. Those can go together just like that. And it's going to be over 24. What about the next piece? 1 times that negative 8 is a negative 8 over 24. And you could reduce down that negative 8 over 24 into a third. But it really doesn't matter because we're going to get rid of them. And if you have trouble with the fractions and understanding how these work, you can always write them over to the side. Like, how did I get that 8 over 24? Well, that's 1 over 24 times a negative 8 over 1, right? And that's just a negative 8 over 24. And again, you could reduce that down to a third, negative 1/3, but it really doesn't matter because we're going to get rid of it. If you want to reduce it, that's fine. However, we really don't need to because all the fractions are going to be gone in just a second. Look at all the denominators. I have a 3, I have a 4, and I have a 24. So what's my largest denominator? Well, it's 24. Okay. Now, does 24 evenly go into 3? Yeah. Okay, it does. Does 24 evenly go into that 4? Yeah. So 24 is going to go into all the numbers. So we're going to multiply everything, that's your least common denominator, by a 24. Okay, because 24 will go into the 3 and the 4 also. So now we've gotten to this point, and we're going to clear these fractions. So how is that done? We divide by the number down below, multiply by the number on the top. divide by below, multiply by the number on the top. So 24 divided by 3. Well, 24 divided by 3 is an 8. And 8 times 2 makes it a 16, and we'll bring down the y with it. Then we've got 24 times a negative y. Well, that makes it a minus 24y. Then we've got 24 divided by 4. And 24 divided by 4, that's a 6. And 6 times 1 makes it a 6. We're on the right track here. When I distribute through on the other side, on the right-hand side, 24s, they cancel. That leaves you with a y. The 24s, they cancel. That leaves you with a minus 8. Is everyone okay with how I cleared out those fractions? Now we're going to work on the left-hand side, and we're going to clean it up a bit. So we've got 24 and 16, and that should be an 8 there. And which one's larger? 24, it's negative. So that's going to be a minus 8y. And then we've still got the plus 6, and that equals y minus 8. Proceeding, we're going to move that y over with subtraction. And that makes it now a minus 9y. We move it over. Plus 6 equals a negative 8. The 6 needs to be moved over with subtraction. And now we've got minus 9y equals, looks like a minus 14, isn't it? Okay, yep, everything looks right there. We're just making sure we don't make a mistake anywhere. Everything looks right. We're double checking our addition and subtraction. And now how do we finish it out? We divide by what now? Yep, negative 9. And what happens when a negative gets divided by another negative? Positive. And then that comes out to be a positive 14 what? 14 ninths there. Is everyone okay with how I solved that one? So we distributed through, we combined like terms, then we cleared our fractions, then we solved it. And most of the time your answers will be whole numbers, but not always. So you can get a fractional answer like this one. That was question 11. Question 12 is more fractions here. And they'll get a lot easier. Once you start learning how to clear them out and work with the fractions, they're not going to be difficult at all. So for question 12, we've got 1/4 times x plus 8 plus 1/2 times x plus 2 equals x minus 9. And we'll distribute through. One-fourth times x, you can write that as 1/4 x, or you can write that as x over 4. They're the same. What about 8? 8 divided by 4, well, that is a what? 2. Okay, so you can write it as a 2, or you can write that as 8 over 4. It doesn't matter, because they're going to be cleared out in a moment. So 8 over 4, or you can write it as 2. Next piece gives you 1/2 x, or x over 2, either way. You can use them interchangeably, just like I did here. It doesn't matter. We know this is the same as 1/4 x, and this is the same as x over 2. And a lot of times we use them interchangeably. What about 1/2 times 2? Well, what's half of 2? Half of 2 is a 1. Now we can clear our fractions. So what do we have for our denominators? We have a 2 and a 4. 4 is going to clear them all out, won't it? So we're going to multiply everything by a 4. And we could have went ahead and combined the 1 and the 2 together there if you want, or you can just multiply by 4 at the beginning. It doesn't matter. I would just say go ahead and get rid of the fractions now, and then we'll deal with the leftovers. I think for the majority of students, the quicker we get rid of the fractions, the better, because they're just kind of intimidating, and if we can clear them out, we're less likely to make a mistake. So again, we could put the 1 and the 2 together, but we'll just clear it out first. So 4 divided by 4, that's a 1, times x, that leaves you with an x there. 4 times 2 makes it an 8. 4 divided by 2, that's a 2, times 1, that makes it a 2. It has an x attached with it. 4 times 1 is 4. And don't forget the right-hand side. 4 times x, that's a 4x. And 4 times negative 9, that makes it a negative 36. And there's different ways of working this one out. What do we want to do, though? We want to get rid of our parentheses and then clear our fractions. So always do your parentheses first. You might reduce your fractions down more. You might combine them together. I'm just going to get rid of them at the very beginning. And now we've got this. So what do? Combine like terms. So we have an x and a 2x. That makes it a 3x on the left-hand side. We have an 8 and a 4. An 8 plus 4. Well, that makes it a 12. On the right-hand side, we have a 4x minus that 36. We'll go ahead and move that 4x over with subtraction. 3 minus 4 leaves you with a minus x there. And you've got 12, and that equals a negative 36. We'll move the 12 over with subtraction. Now we've got negative x equals, what, negative 48, I believe. Those will be added together. Yep, negative 48. This is a commonly made mistake. A lot of times students are going to say, well, the answer is negative 48. Is the answer negative 48? No. Okay, commonly made mistake. We are not completely done. How do we fix that? Divide both sides by negative. And that leaves me with my variable on the left that is positive. And negative on the right makes it a positive 48 as well. Okay, so is everyone kind of all right with that? Fractions are just a little bit more difficult, but we do just want to get rid of them as soon as we possibly can. Question 14. So question 14 is more fractions. And we've got 2/5 x minus 1/3 x equals 5. Well, we're in luck because there's no no parentheses to worry about. So all we have to do is clear out our fractions. And what are our two numbers in the denominator? Yep, 5 and 3. And least common denominator of 5 and 3 is going to be that 15. So we're going to have to multiply everything by a 15. So we divide and we multiply. So 15 divided by 5 is 3. 3 times that 2 makes it 6x there. We'll bring down our negative. 15 divided by 3 is 5 times 1 makes it a minus 5. And we'll bring the x down with it. And then we've got 15 times 5. I believe that's 75. me double check myself though. Yep, should be 75, and it is. This one's almost done. What do? On the left, combine 6x minus 5x. That leaves you with a single x. And that now equals 75. Are we done? Yep. The x is by itself, and it equals a number. So we know we have finished that problem out. Do we have any others we need to add in from 2-3 and 2-4? Are there any others? How about the decimal ones? Did we understand how to work with something like 16? Do we need to look at 16, or do we understand that? Sure, yep, we can add 16. Yep, we can add 9 also. We'll do 16, and then we'll come back and get 9. Now, for question 16, we're going to be using our calculator. You could clear out the decimals, but I think that's really more confusing, and you're more likely to make a mistake than just simply using a calculator. And when you work with these decimals, make sure you have the correct number of zeros. So let's double check and make sure we wrote it all correctly. Yep, that all looks right. It's easy to lose a decimal point. Okay, so we're going to go ahead and distribute this through. And we'll multiply on the left-hand side as well. Okay, so the first piece on the left is this. This is a decimal here, so we're just going to use our calculator. 0.028. We're going to multiply that by 500. And that comes out to be 14. Plus 0.07x. What are we going to do for the next piece? We're going to distribute that 0.04 through. Take that 0.04, we're going to multiply that by 500, and that gives you now 20. And you multiply it by x, it's just 0.04x. Now what do? Well, decimals just work like any other number. We get all the x's to the left, numbers go to the right. So move that 0.04x over. And that leaves me with then 14. And those are going to subtract from each other. The 0.07 is larger, it's positive. So that's going to be a plus 0.03x. And you can use a calculator if you want to. And that equals now 20. Don't ever hesitate to use a calculator. I'd rather you use a calculator than make a mistake. So if you're not good with mental math, just use a calculator. You can use a calculator in all your other math courses. We have it. It's a tool. If you need to, use it. So we're going to move that 14 over with subtraction. And now we have a 0.03x on the left. On the right, we've got 20 minus 14. 20 is larger. It's positive. And 20 minus 14 leaves you then with a 6. Okay. And how do we finish it? Well, like any other number, we divide. So divide by 0.03 on both sides. And you'll need a calculator here. So we've got 6, and we're going to divide that by 0.03, and that's going to come out to be now 200. So what do we do with the decimals? We just use our calculator. Right? The textbook shows you how you can clear the decimals out. I think you're more likely to make a mistake by clearing out the decimals. Just use a calculator. And we also added 9 to the list. And that is 0.39 times x plus 60 plus 0.38 times x plus 50. And that equals a minus 42.3. Okay, so just like with the fraction or anything else that has parentheses, we do those first. So we're going to have to distribute our decimals in this case through. We're going to use our calculator so that we don't make a mistake. And 0.39 times x, that's simply 0.39x. And for the next one, we use our calculator here. So we have 0.39. We're going to multiply that by 60. And that gives me my 23.4, it looks like. Next piece is going to be 0.38x. And then you got 50 times that 0.38. That's going to give me a whole number of 19, it looks like. And that equals a minus 42.3. Combine. So these can go together. And we've got 0.39 plus 0.38. That gives me a 0.77x. These can go together. And so we've got 23.4 plus that 19. That comes out to be a 42.4. And that equals now minus 42.3. Move it over with subtraction. So move that 42.4 over with subtraction. And that gives me a 0.77x. These are the same, so they're going to be added together. You know our sign's going to be negative. And we'll just put those together. So 42.3 plus 42.4. That gives me 84.7. Divide by our 0.77. That leaves me then with, when we divide, if we use our calculator, negative divided by positive. If you use your calculator, just divide them. Your answer is going to be negative, and that's going to come out to be a negative 1/10. Because I just divided. So that's going to be your answer on that. So hopefully that was a good review of how to solve these equations. Very, very important that you understand how to solve these because everything is going to be based upon solving equations. So we've got a little bit of time, so we'll start a little bit out of 2.5 and then we'll take a short break. 2.5, we're going to be working with applications. These are where students struggle. How to write the equation up, how to solve it, and then how to make sure that we answered the question. So we're going to spend a lot of time learning how to solve these applications because they're very, very important. So we're really going to focus a lot of time on how to solve these. The later chapters are easier than this one when we look at the applications. So we're going to be looking at 2.5, and we'll pick some questions from our textbook to look at. And I'm going to be on page 141. So we'll probably do 2 or 3 of these, and then we'll take a short break. So we're going to start with question number 9. Now, whenever we look at an application, what we're going to do is we're going to read it through once. We're also going to read the directions and make sure we know what we're supposed to be accomplishing. So let's read the directions first. It says solve each problem. In each case, give an equation using the variable x and give the answer. So we need to find our equation. We need to solve it. So equations are going to have equals. And so this one is going to have an equal sign, and we're going to be able to solve it. We've done these a little bit before, back in the last chapter. We're going to look at these again here. So the sum means add. So the sum of a number and 9 is negative 26. So this is a pretty easy one to start with. So we want the sum of a number. Okay, so when we talk about the number, that's going to be replaced with the x. And this is going to be again on page 141. We're going to be looking at question 9. Okay, so sum of a number and 9. So the sum of a number and 9, that's going to be x plus 9. Is everyone okay with that piece? Now, is. What does is mean? Is means equals. So that's going to be our next component here. Equals. And what does it equal? Negative 26. Now we can easily and very quickly solve this one out. So what do? Move the 9 over. And that leaves you then with your answer of x equaling now a negative 35. Okay, so there's that. Now they do get a little bit more difficult as we move along. Let's look at, how about question 12? So we're going to look at 12 now. And what do we have on question 12? Okay, question 12 says the product of 5 and 3 more than twice the number is 85. Now, where we see that and, when it says the product of 5 and, that means we're going to have parentheses around that. Because we're going to take 5 and we're going to multiply by everything behind it. So we're looking at the product, that means multiplication. We're looking at the product of 5, 3 more than twice the number. Well, what would twice the number be? Twice the number would be 2x. So let's see what we've got. We've got the 5 out in front here. And then it says it is 3 more. So that's going to be a 3 and a plus. Twice the number, which is 2x. Is means equals. And in this case, it looks like it equals 85. Is everyone okay with how I did that? So the 5 was out in front because of the and there. Distribute that 5 through. And that leaves me now with 15 plus 10x equals 85. We'll move that 15 over. Now we've got 10x equals, looks like 70, isn't it? Because we've got 85 minus 15, that should leave you with the 70. And we'll divide by our 10. And my final answer then is going to be x equals now 7. Let's try another one. That was 12. Let's go to one that's a little bit more difficult. How about we look at 19? So move it up so we can see it on the screen. We're going to be looking here at question 19. Oops. Now we can see. Okay, so we're looking at question 19. And it says the sum of 3 times a number and 7 more than that number is the same as the difference of minus 11 and twice the number. What is the number? So let's first see what we've got. So the sum of 3 times a number and 7 more than the number. So what would that look like? Let's think about what we've got here. 3 times a number. Well, what's 3 times a number mean? 3 times a number would give us now, this is question 19, 3 times a number, that's going to be that 3x. And what do we have to do after that? We're going to sum it together with a number and 7 more than the number. Okay, so 3 times a number and 7 more than the number. Well, 7 more than the number would be then x plus 7. You could put parentheses around it if you want. We really don't need to, though. So we've got 3 times our number. We're going to add then the number plus 7, so that's x plus 7. Oh, sorry about that. Yeah, it's hard to see it all. Sorry about that. Okay, so we've got our 3x there. Okay, we've got then x plus 7 here. And if we go back and read question 19, that's the first half. Okay. Is the same as. So is the same as, what does that mean? Equals. Okay. And that's going to be the equal sign here. Oops. Okay, so there's that piece. And what is it going to equal? Well, let's see. Is the same as the difference of negative 11 and twice the number. So difference means subtract. So we've got negative 11, and we're going to subtract from that negative 11 twice the number. So that's going to be a what? Minus 2x. So that's going to be our equation. So we've got 3 times our number. That represents that 3x there. We're going to add to that a number plus 7. So that's there. And we're looking at the difference of minus 11 and twice the number. So that's minus 11 and a minus 2x there. Now we've got it. And this is question 19, by the way. Now we've got our equation. We can solve it. So what do? Those can be combined together to give you 4x plus 7 equals a minus 11 minus our 2x there. We're going to move things around. So I'm going to go ahead and move that 2x over. Now it's negative, so I'm going to have to add it to get rid of it. And that leaves me now with 6x plus 7 equals a negative 11. And a couple more steps here. Move the 7 over with subtraction. So 6x now equals a negative 18. And what's my next step going to now be? Next step is divide by what? 6. And that leaves me then with my answer of x equals now. Watch your signs. Negative over positive makes it a negative 3, isn't it? Is everyone okay with how I solved that one? And that one was just taking all those words, figuring out where they went and what they're doing. Let's try one more. These are going to be a little bit different. We're going to try one of these new applications, and then we'll take a short break. So one more, and then we'll take a short break. Now, the next ones that we're going to be looking at involve a total. And so now we're going to move on to the next page, and we're going to look at question 23. Okay, and this one's going to involve a total. New York and Ohio are among the states with the most remaining drive-in movie screens. New York has 4 more screens than Ohio, and there are 52 screens total in the 2 states. How many drive-in screens remain in each state? So we read the question out. Now we're going to go back and we're going to try to come up with an equation. We're going to try to solve this equation, and then we're going to make sure that we answer the question. So first off, what do we have? Well, we have these 2 states, and so we're looking at New York and Ohio. So we're going to label them New York and Ohio, and then we're going to use that information to kind of make our equation. We're going to work with words first, and then we're going to use the variables. So this is question 23. So we've got New York, and we've got Ohio. And we need to see how these relate. Well, if we read it, okay, the first sentence just talks about the drive-in movie theaters. And it says New York has 4 more screens than Ohio. So New York has 4 more screens than Ohio. So New York is going to be Ohio plus 4. We're going to work this out in terms of words first, and then we're going to add in the variables. So does everyone see where I got that from? Okay. So New York has 4 more screens than Ohio. Now, one of these we know nothing about. We know nothing about Ohio. All right, so Ohio is going to be the variable x. So we don't know what Ohio is, so we're going to call that x. Now when we rewrite, we're going to use the variable x. And so now we have New York. Well, that's Ohio plus 4, but we called Ohio what? X. So New York is going to be x plus 4, and Ohio is x. So we've got the variable x used. Now we need to come up with our equation. Well, what do we know? When we read this, it says there are going to be 52 screens total. So the total is 52. And what is that total? Well, that total is New York plus Ohio. So we have to use the fact that we have a total. So that total is going to be New York and Ohio. And what do we know about New York? Well, New York was what? New York was x plus 4. So it's going to come down as x plus 4 there for New York. And what do we know about Ohio? What was Ohio? X. And what is that now going to equal? 52. Now we finally have an equation that we can solve. It's simple to solve. Combine makes it 2x plus 4 equals 52. We'll move that 4 over with subtraction. Now we've got 2x equals 52 minus 4. That makes it a 48, I believe. We'll divide by our 2. And now we've got x equaling 24. But that is not our answer. We cannot stop here. That's only part of it. So we got x equaling 24. So what does x go with? Let's go back up and look. What does x go with? Okay, x goes with Ohio. So the 24 goes with the Ohio. So Ohio has 24 screens. So there's that piece. We want to find both of them. So we know Ohio has 24 screens. Now, what about New York? Well, New York has 4 more. So New York, well, it's going to be x plus 4. So that's going to be 24 plus 4, which is then 28. So now we know that New York has 28 screens. I'll move it so we can see here, but New York has 28 screens. Now, how can I check it? Well, to check it, if I wanted to check it, we've got 24 and 28. What does that come out to give you? If you add them together, okay, 24 and 28, that gives you what? 52. Is that how many screens that we should have total?
Yes.
Yes, it is. These are a little bit tricky as far as the setup. And so this is the first type of application that we're going to look at, where we have 2 pieces and we compare them. Normally we have a total. We'll take a short break, and then we'll come back, and we'll look at some more of these. So let's meet back here at, let's say, 9:35. So let's meet back here at 9:35.